last summer I bought this beautiful heater, and it is already second time when I need to fix it. In the beginning, the problem was that it was not reaching temperature above 65 degrees. Then the relay broke. Then I brought entire thing home to fix. Also fixed the heating issue, moved the thermostat sensors a bit lower. Then on February I supposed to have my birthday party in the sauna, and this thing refused to work. The thermostat was thinking that negative temperature is the same as overheat, and I couldn't reset it, because to make that reset button work, you need to heat up entire thing up to 18 degrees. So I needed to remove stones to bring that thing home. Here are all components from this heater. So first is timer. It basically works as a switch with the time. Then it controls this relay. While the timer is on, the relay is on, and then thermostat basically takes care about temperature, and it also has overheat protection. So the biggest troublemaker is this one. The first part to break is the relay, and a strange thing that the timer is three-phase, and I checked the specifications. It is rated for 16 amps. It's basically the same as this relay, so I don't really understand why they just connect directly from timer to this one. Probably this one has some other problems. Okay, the relay, that orange thing inside is electric magnet. So these two are the control lines, and this is the contacts for every phase. So when control line gets power, so the magnet is on, it attracts these contacts, and it gives, let's say, connects those pins. The reason why this relay breaks is because of this thing. Here is kind of tubes. So the liquid or some kind of gas in those tubes expand, then it slowly pushes the button, and that button, let's say, disconnects the heating elements itself. The big problem in all those power lines are the moment when you switch on or switch off. It is called a transitional process. When you connect the line, there is a big jump in current and drop in voltage, and when you disconnect, there is a big jump, let's say, or spike in voltage. This thing is on and off every like 30 seconds, and it is very slow. So when the contacts opens inside this, it creates arc or little sparks, what basically damages this electric magnet. It is possible to solve that, let's say, by adding this part. It's called snubber or varistor. So it basically absorbs all the shocks created by thermostat. But yeah, the thermostat is not working in negative temperature, so I will completely change those parts. So instead of this switch with the time, I will be using switch on the wall with this timer. It is called operational timer. It is set to 2 hours. So basically, when you switch on, it will work for 2 hours and will then cut the power. If you need more than 2 hours, you basically will need to re-switch the switch on the wall. Instead of this tiny relay, what works on 80% of its rated power, it's rated for 16, and the heater takes 13. I'll be using this industrial contactor. It is designed to control electric motors. It is also designed in a way that it deals perfectly with those sparks during the disconnect. It has kind of special chambers inside what reduces those sparks. So the braking force it's amazing. Actually, you could see here a little spring, what probably 10 grams of braking power. This one probably has 1 kilogram. It's basically the same as comparing child's tricycle with a truck. There is no chance that those contacts will melt together or that electric magnet will break. I will not be using temperature control at all, but I will be using overheat protection, because there is a little chance that this might not work, not because of electric reasons, but because of say mechanical reasons. Let's say there is a little hole what opens, so if some bug decides to sleep in that gap, so this thing will not, let's say, close. So you probably heard the term debugging in the software development, and that literally meant removing bugs from relays, because first computers were relay based. About overheat protection. So if this thing once in 10 million time breaks, so then your switch on the wall will not work and your timer will not work, so you need to cut power somewhere else. So you probably have leak protection breaker. This is one phase. You probably have 3 phases, but I couldn't find 3 phases at my home right now. So basically there is a mechanism to detect if there is a difference in the current, what's coming in and what's coming out. If there is a difference, let's say, in current, so this thing understands that current starts to flow somewhere to the ground through somebody's body. It works on 30 milliamps, 30 milliamp current. So if it's more than 30 milliamp, then it breaks. There is a test button. If you press that test button, it basically creates that leak artificially, and then this is the way to test if it's working. Let's say. And there is a little schematic on the side. I printed that big. So the schematic is like this. There is a mechanism to check the current. There is this test button. What test button does, it connects the output of live line through a resistor. Resistor creates 30 milliamp current, and it connected to negative or neutral input. So it's basically bypassing 30 milliamp currents around this thing. So if you take this one and take the same resistor and connect it, let's say, from live output to neutral input, so this relay will break also. So if you connect that here, and on the long wire you connect this guy, this is called thermostat switch. It is used in electronics everywhere where you need to monitor the temperature of radiator or whatever. It's used in power amplifiers, batteries, and chargers, whatever. This is, let's say, waterproofly sealed in the heat resistive plastic, so it will work perfectly for this application. So next wire you should connect to the neutral input. It is not good to screw that to the wood directly. You should do that through some metal, leave a little gap, so then it will read temperature correctly. This is rated, this particular is always normally open. When it reaches 120 C, it closes connected. it will work the same as pressing that button basically. And the last thing I added this snubber or varistor here because the electric magnet inside is kind of powerful, so the magnet itself will create kind of shock. So this is basically lifetime insurance for this guy to filter out all those spikes. So I think the system will be bulletproof, and it works in minus 50 degrees Celsius.